In this video we are going to talk about the types of systems in thermodynamics. As you can see, there are 5 based on 2 different major types. So let's go. First is the based on exchange, based on what can be exchanged. The first is the open system. The open system, let's say, what happened? Oh no, wait. There is a beaker and there is water, and there is an open beaker. This open to atmosphere, this beaker is. So we can see that this beaker has normal temperature water, can take heat from the atmosphere and evaporate so basically it can also, it reduces its particles from the water, so it can exchange matter and it can also exchange heat from the surroundings. Let's consider this as an imaginary boundary. You can also consider this as an imaginary boundary. Anything where the interfaces, you can consider even very close to the surface, because the vapor starts right from there. So it takes heat, it turns vaporizes. So it basically it is exchanging both heat and matter. Temperature exchanges heat. Heat basically energy. So exchanges heat and energy and matter both. That is the open system. Now we go to the closed system. The closed system is not much difference, but only one thing. Again we have the beaker, again there is water, and now only difference is that it is closed. This beaker is closed. The beaker does not, it's not, the beaker is like this basically. The beaker is like this. I don't know why I'm making like this. The beaker is like this, and the beaker is closed. So now let's say that there is hot water here. There is hot water. The hot water again evaporates, but this time it cannot cross this real boundary. This real boundary cannot be crossed this time. So basically again this time it can exchange heat, but it cannot exchange matter. So this is the basic difference between open system and the closed system. It can exchange both heat and matter. It only exchanges heat but not matter. And even if there is not hot water, it is only cold water, again it will take in heat from outside, evaporate, but it cannot exchange it with the surroundings. It is close to the surroundings. That's the basic difference between open and closed. And now there is the isolated system. The isolated system. This is one such system where I make a perfect beaker, square rectangular beaker. There is another boundary here. This boundary is, this is a very compact, this boundary, again there is some water in this beaker. There is again some water, and let's say this time there is hot water here. So in this beaker this time it will again evaporate, but this won't exchange with the surroundings, And the other thing is that it won't take in heat from outside, neither will heat go outside. This won't happen here. Happen here. Neither will heat come in nor will it go out. It will always be the way it has always been. It will be constant, this thing. And not the percentage of vapor in water, but the temperature will be constant. The matter which will be inside this will be inside this. But the truth is that no system is perfectly isolated. No system can be made perfectly isolated. So the only example we have is of a thermos flask, if you have heard about it. It is used to store hot tea or hot coffee or hot water, anything. The thermos flask. The closest we can get to the isolated system is our own universe. The universe is the closest. Because you see, we don't know basically the first point is the total mass. The mass and energy is the constant in the universe. The mass and energy is constant. Second point is that it has no boundary. We don't know anything outside of our universe. Let's see, universe, right here, universe. Constant mass, energy. There is no boundary. There is no boundary because we do not. It's all expanding. There is no boundary to our universe. So this implies, because there is no boundary, there is no surrounding. That is what it implies. If there is a boundary, only then will there is a surrounding. No surrounding. Then these are the three major points. That energy and mass is constant, no boundary and no surrounding. These are three major points. That the universe is the most isolated system, the closest we can get to the isolated system. The ideal isolated system. And in the lab maybe we can get to a closer isolated system, but in general the universe is the closest. And also there is, like here, there is exchange of matter within the vapor and water. Similarly, there are many processes within the universe, which exchange temperature, mass, heat, everything, but it simply doesn't get out of the universe. That is it. Therefore the universe is the closest. Now we get to the fourth and fifth types of systems based on the types of particles, and these are the homogeneous systems and the heterogeneous systems. So the homogeneous, homo is basically, you will not be able to tell one particle from the other. You will not be able to draw a boundary. If you can say that there are two components. I'm not saying, there is something called previous knowledge. And there is observation. If you observe that there is only one component, then it's a homogeneous system. If you observe that, you may have previous knowledge that there is alcohol and there is water, but what will you observe? You'll observe that there is only one component, because these are miscible liquids. If once they are mixed, you cannot say which is alcohol and which is water. So that's what I'm trying to say. You will see that there is only one component. It can also be gas. It can also be one solid, one zinc block, something like that. So it's only one component. It's homogeneous. You cannot even draw an imaginary boundary. It is homogeneous. And heterogeneous is, there will be a boundary, like water and oil. There will be a boundary, like anything, heterogeneous system, anything. If even this system in which there is water till here and there is vapor here, this is an heterogeneous system. You can draw an imaginary boundary here. This is an imaginary boundary here. This is a heterogeneous system because there is two components. This is a heterogeneous system, just like water and oil. It can be said that there are two components inside. So these are the types of system.